Hello again everyone, welcome back to ptet.chemistry channel. So my name is Mr. On, and in this tutorial video I'll cover the work solutions, the walkthrough tutorial for this work 2 of the atomic structure. This is atomic structure for the students studying the chemistry 5070 syllabus, which is the Cambridge International O-level chemistry exam, and it's similarly applicable to anyone doing the IGCSE or GCSE curriculum for chemistry, whether you're doing the extended or the core. Atomic structure is a key topic, and all of atomic structure will have been included, with the exception of the calculation of relative atomic mass, which is quite new in the 5070 syllabus as well. Question 1 here, we have a radioactive isotope. Radioactive meaning unstable nucleus, something that you would most likely do in nuclear physics rather than in chemistry. So this is a given isotope of it, and this 201 is the mass number, 81 is the proton number. So we know that 201 is also the nucleon number, which is the number of protons plus the number of neutrons is equal to the number of nucleon, which is the sum of the number of protons and neutrons in the nucleus of an atom. So that one would have been 201. So A is wrong, and you're looking for something which is correct. The number of electrons in one atom. So when you have atom, your number of protons equal to number of electrons, because overall no charge. So how many protons do we have? We have 81 protons, so we will have 81 electrons, and that is precisely correct. The number of neutrons is not 201, it's going to be 201 minus 81 equal to number of neutrons, and without doing the calculations I can tell you it's not 201, because 201 minus 81 is not 201. This thing, they say X is an isotope of this element thallium, and it is not correct, because this element 82 is not equal to 81, and proton number is the identity of the element. So if the proton number is different, they cannot be the same element. Okay, so C and D are also incorrect. Next bit is about ammonia. You have heard of ammonia, and you have included it as part of your chemistry vocabulary after you've done a little bit of ammonia in diffusion topic back in stats of matter. So if we know how to work out the number of electrons in nitrogen and hydrogen, we can do it for a molecule. When you have a molecule, there is no charge, no overall charge. And there is no overall charge because the number of protons equal to the number of electrons. So it's kind of similar to an atom, but here you have a molecule. So the number of protons is going to be 1 nitrogen times 7 protons, 3 hydrogen times 1 proton. So 7 plus 3 is 10 protons. Therefore, the number of electrons equal to 10 because of this. Right, so what's the total number of electrons in one molecule of it? It's going to be 10 and not anything else. Okay, you just sum out the number of protons from the nitrogen. You have 1 nitrogen. Each nitrogen atom has 7 protons. And then you have 3 hydrogen. Each hydrogen atom has 1 proton. Altogether you have 10 protons in the molecule, which has no overall charge. Therefore, the number of protons and electrons are equal in the molecule, which has no overall charge. So that will be 10. Question 3 is something similar. So which two molecules contain the same number of electrons? Yeah. So for chlorine, how should I do this? Okay, if I do chlorine, SO2, proton, there will be 17 times 2, which is 34. For sulfur dioxide, SO2, you can have a look in the periodic table. Sulfur is element number 16, so it's got 16 proton. There's 1 sulfur. You got 2 oxygen. Oxygen has a proton number. This is proton number. This is not mass number. Be very careful of what you're doing. 16 plus 16 is 32. So 34, 32. We know that these are molecules. So I can go on and do 34 electrons, and there will be 32 electrons because this molecule have no charges. So the number of electrons equal to the number of protons. 34 is not the same as 32. I can cross them out. Alright. So how about B? B is CH4 and H2O. My proton is 6 proton for carbon plus 4 times 1 for hydrogen. And you can do the same thing for the H2O as well. You're going to get 2 times 1 plus 8 times 1, which will give you 10. And the number of electrons is going to be 10 and 10. As you can see, they have equal number of protons and therefore equal number of electrons, since both are also molecules. So be very careful whether you're calculating the number of protons or are you working on the relative molecular masses. Okay, so those are the common things they like to trick students with. Back in topic 1, when you did diffusion, we talked about the relative molecular mass using the mass number. Here is counting the number of protons in order to work out the number of electrons, because the number of electrons equal to the number of protons for molecules which have no overall charge. You can do the same for C and D, but you will find that, having gotten to the answer correctly, there's not much point of going on. But for practice, you should really work out the number of electrons for each and every one of the other examples, just to convince yourself. Yeah. Question 4 is one of those new addition to the Chemistry 5070 syllabus, where you are expected to calculate relative atomic mass, which is to do with average mass of blah 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 relative to 1/12 of the mass of an atom of carbon-12. Those are your fixed definitions. They are worth 2 to 3 marks. Very easy marks. You don't want to be losing them at all. Okay, so this is copper, and you have copper 63 and copper 65. These are relative abundance. They are not percentage, but instead they are ratio. Do you do the same thing? Yes, you do the same thing. So the abundance there is 7 times 63. So use bracket carefully and then add them up. This is 3, so 3 times 65. Use bracket to close up because there is no other isotopes in the abundance, and then divide by the sum of the abundance. Instead of divide by 100, here divide by 7 plus 3, because that is what I have used for my calculation. So pop that into your calculator. 7 times 63 plus 3 times 65, that is 636 divided by 10, and I get 63.6, which is option C there. Question 5, you have carbon 14 and you have carbon 12. They are both isotopes of carbon. So we know that isotopes are atoms of the same element with the same number of protons but different number of neutrons. So first question is talking about reactivity. This is incorrect. Isotopes have the same chemical reactivity because it has the same total number of electrons. If you have the same total number of electrons, your valence electron is the same, and therefore you have the same chemical reactivity. Okay, so more reactive is both incorrect because isotopes have the same chemical reactivity. The reactions are similar, okay, because they have the same number of outer shell electrons. Okay, this is a correct statement. They have the same number of protons. Hang on, let me see. The reactions are similar because they have the same number of outer shell electrons. So this is to do with valence. So this is a correct fact, but incorrect reason for chemical reactivity. When we're talking about chemical reactivity, we are talking about the reaction of the outer shell electrons and got nothing to do with the nucleus, because there will be nuclear chemistry, nuclear physics. Nuclear chemistry is essentially nuclear physics, okay? It's essentially just physics. When we talk about chemistry, it's to do with electrons, it's to do with your outer shell electrons that react, okay? So a correct fact is not necessarily a correct reason for the observations that we are talking about. So be very careful of that, yeah? Next question. In which pair do the atoms contain same number of neutrons? So this is one of those questions that, you have got to set up them properly. Boron is element number 5. You can get that from the periodic table. Carbon is element number 6 from the periodic table as well. So boron is element number 5, so it's 5. Carbon is element number 6, so there's 6 protons. but they want the neutrons. So really I wouldn't really need to work out the protons at all. I just need to work out the neutrons. There's the mass number, nuclear number, minus the proton number. There's 6. There's 12 minus 6, which is 6. Well, there you go. I got the answer already. Okay, so I could go on to the next one. Lithium is element 3. I mean, I could move on to the next question already, but just want to show you a couple more how to do them. So 7 minus 3 is 4. 9 minus 4 is 5, and so on and so forth. Okay, so I wouldn't go through the rest of the example, but for practice, I guess if you know what you're doing, you know what you're doing. If you don't know what you're doing, you should practice again. 24 minus 12. 12 is the proton number you get from the periodic table. 28 minus 14, which is element 14. There's the proton number for silicon over there. 14 minus 7. 16 minus 8. So those proton number you can get from periodic table easily, yeah. Number 7, so you have a mass spectrum kind of question. You need to work out the relative atomic mass, which is to do with the average mass again. You need to talk about 3 significant figure. So this is a little bit of your maths, talking about significant figure. Isotope 6 versus isotope 7. So 6 times 7.42 plus 7 times 92.58. Here I do have percentages, and the percentages actually add up to 100%. Make sure you use bracket carefully. So a lot of people are very careless with the use of bracket, and by being careless, you are being careless, you know, you're throwing away what could have been yours, but you choose to be careless, so you're throwing everything away. So I'm writing all of them down first, but I need to 3 significant figure. So 3 significant figure mean 1, 2, 3. So I look at the next one. So I need to add 1 because it's 5 or greater. So 6.93. That means that's the 3 significant figure. Question 8. There's this unusual anneal pentium. It's an artificial element. One of its isotope is this. So this is one of its isotope. So this particular isotope, it has a nuclear number 105. It's incorrect. The nucleon number should be 262 because nuclear number is the mass number, should be 262. Alright, so that is incorrect, and you want a correct statement. The next bit, so 105, 105, so they are the same element, so that's good. 260, 262, so same number of protons but different number of neutrons, is an isotope, so B is actually correct. Yeah. Next bit is talking about the number of neutrons is incorrect. The number of neutrons is equal to 262 minus 105. And I mean, I don't need to calculate it, but you know, just want to show you that there's actually 157 neutrons and not 262 neutrons, because that 262 is actually nucleons, which is the sum of the proton number and the sum of the neutron number. The proton number is that number at the bottom. So despite how your periodic table show you, where you know, your periodic table will have shown you like carbon, what is it, 6 and 12, like this is periodic table. When we writing or I don't know, explaining, we don't use the convention in the periodic table. Okay, we will write 12 and 6, and we don't write them in the middle. It's always on the far left. The proton number at the bottom, the mass number on top. The proton number at the bottom, the mass number on top. So 262 is incorrect. It should have been 105. Fairly straightforward there. Question 9 onwards is something to do with structured questions. So define the following term. Mass number. So mass number is the same as nucleon number. Is nucleon number. And what is nucleon number? Which is total number of protons and the neutrons. Where are they? In the nucleus of an atom. If you don't like the total number, you can use the term which is the sum of the number of protons and neutrons in the nucleus of an atom. They are the same thing, yeah. Valence electrons refer to valence electron is the outermost shell electron. So the electrons that fill the outermost shell furthest away from the nucleus. Relative atomic mass is to do with average. So your answer has to have average, okay? It is the average mass of an atom of the isotopes. It's the average mass of an atom of the isotopes of an element. Nice, alright. Of an isotope is fine. Of the isotopes relative to mass, relative to 1/12 the mass of an atom of carbon-12. So carbon-12 is the, well, basically it's the isotope of carbon, or you can write this one carbon-12 is the same thing, okay? So whether you write carbon-12 like this or you write carbon-12 like this, yeah? So that is important, 1/12, because we're comparing the mass of one atom. In fact, it's the average is very important, mass of one atom. We have to compare to the mass of one atom as well. N refers to 1. It's just we use N instead of a because of the vowel A, E, I, O, U, yeah, from your primary school mathematics. Primary school English, not maths, okay? Isotopes. Isotopes are atoms of the same element. That have same number of protons but different number of neutrons. So it's to do with what is the same and what is different, okay? But the key feature really is what is different, yeah? So different number of neutrons. So this definition itself are very important. I don't know why itself is given just 1 marks, but if you are in A level, so these are typically 2-mark definitions, okay? Atoms of the same element, because they belong to the same element, they're just different kind of atoms. Same number of protons, but different number of neutrons. Okay, part B, element X has mass number 24, atomic number 12. So this is the proton number. This is the nucleon number. So I can write element X as 12 at the bottom, 24 on top. Okay, and then element Y has mass number 27 and atomic number 13. So I can write them like this, yeah. Why is it that a new element not be discovered that might fit between X and Y? Okay, so the elements are arranged in the periodic table in order of increasing proton number, yeah. So I hope you know that, you're aware of this. Elements are arranged in order of increasing a number of protons. So element number 12, hang on, I want to talk about there is no possibility for basically between 12 and 13, there's no possibility of another whole number in between, right? It is impossible, it is not possible to have a partial or fractional proton number to fit in between 12 and 13 for X and Y respectively. So what am I saying? I'm saying basically it's just that, you know, whatever you're saying that, you know, 12 is the proton number of X, 13 is the proton number of Y. Between 12 and 13, you cannot have another whole number in between, yeah? So that's why you don't have another element that is possible to be discovered to fit in between X and Y, which is element 12 and element 13 in the periodic table. Question 10, we need to complete each of these by writing in this value, whether 0, 1, or 1 plus or 1 minus, so the charges matters. The charge on an electron is going to be -1. I know it says 1 minus, but it's actually very rare for us to put down the charge of electron as 1 minus. Okay, so I guess based on the instructions, I should probably follow instruction, right? Considering that I already told you that you should follow instruction, yeah? Charge on a neutron. Neutron have no charge. Number of neutron in a hydrogen atom. So hydrogen atom is like that. It's got 0 neutron. Relative mass of a proton is 1. A neutron is also 1. So the mass of a proton is the same as the mass of a neutron. These are relative mass. Since they both have the same mass, the ratio is 1:1. The relative mass of an electron is actually 1/1840, which is very, very small. So they only say complete by writing this, right? In reality, I would have written this. This is a bad question, but based on this, it would have been 0. So meaning to say, this is what we call negligible mass. The mass is so small compared to protons and neutrons. And then the number of electrons in a hydrogen atom. So again, the number of proton is 1. Therefore, the number of electron is 1 because we are talking about atom. So just 1. Alright? Question 2. Is it question 2? Should have been question 11 actually. Well, anyway. Fill in the names of the subatomic particles which these symbols represent. So these are the hydrogen. Well, they are all isotopes of hydrogen. The nucleon number is the sum of the number of protons and neutrons in the nucleus. So there's only one particle there. So it's just 1. There is a cross and there's a normal circle there. So there's 2 particles there. There are 2 crosses and there's one of the white one. So there's 3 particles in the neutrons. So the one that resides outside in the energy level, so the normal cross has got to be the electrons, being the subatomic particle. And since this one has only one of these blank circles, so the blank circle must be the proton, because they are all the same element. They all have 1 proton. Okay, so number of proton represent the identity of the element, whereas isotope would have different number of neutrons. Here you have 0 neutron, 1 neutron, and 2 neutron. Complete this statement. We already defined isotope earlier. Isotopes are atoms of the same element that contain same number of protons, and they want something else. It's got to be the electrons, because isotopes are still atoms. Alright, so there are different number of neutrons. Okay. Alright, the average mass of an atom. So the average mass, meaning to say the relative atomic mass, yeah, of naturally occurring hydrogen is 1.008. Which of these 3 isotopes is present in the highest proportion? So remember we talked about the isotopes, right? So 2, 1, 3, 1. Okay, and we said that the mass number is 1, 2, and 3, and that means between 1 and 3, your average is very close. Your average mass, by taking into account how many percent abundance of this versus this, is very, very close to 1. It is so close to 1, that you can say that this must be the most abundant. If it is the most abundant, that means 1 time whatever percentage it is going to dominate over the other one, which is not going to be in very big proportion. So which of the 3 isotopes? It has got to be 1 hydrogen 1, and the way we write them is proton number at the bottom, mass number on top, not hydrogen 2, not hydrogen 3, as shown above. Yeah, so this is like a thinking kind of question based on what you know how to calculate the average mass, which is the relative atomic mass. Of course, your periodic table would have just shown you just as 1 being the whole number, because it's really close. Most of them predominantly is basically this isotope hydrogen 1. Alright, so that's the end of this work 2 tutorial, and thank you for watching. Ask me any questions if you've got any to clarify your doubts or anything I said, and I'll see you in the next video.